In this video, I want to show you how to use Ettercap in a dual-stack network where IPv4 and IPv6 address family is active. In this session, we are focusing on the neighbor discovery or neighbor resolution protocol poisoning. We have ARP for IPv4 and NDP for IPv6. I think we have to go through some theory first to understand really why we are using it in a way in Ettercap that it works in the end. ARP resolution is a protocol to resolve the Ethernet addresses from the IP addresses for IPv4. I've just drawn a tiny network here with 3 hosts. A router, 2 hosts, and if the router wants to send a packet to host A, it first needs to know the MAC address of host A, and therefore in IPv4 this sends out our request over broadcast, Ethernet broadcast, and in user cases the host that owns this IP responds back to the router using Ethernet unicast with our reply that the MAC address is what the MAC address is for the host A's IP. The information is being cached and the traffic flows then using this Ethernet information from the one IP node to the other. To poison the situation, that is, as you know it, with Ettercap running on a checker host, it sends out periodically ARP replies via unicast to first the router, telling the router that host A's IP is at the MAC address of the attacker host, and second, it sends to the host that the router's IP is at the MAC address of the attacker host. So this one we know already, and now we will have a look at how it's been done in IPv6 with the NDP poisoning. We have to talk a bit more, understand a bit more how the addresses are being generated and how the routing information is being distributed to the clients. IPv6 supports with an auto configuration of the host IP addresses without a DHCP server. It's called stateless auto address auto configuration, and this one we will go through here. In this scenario, in the initial setting, we have 2 hosts, and when they have IPv6 enabled, they have one address always there. It's starting with FE80, and this means that's the link local address, and the link local address is only valid on this link, meaning this Ethernet segment. And this one has every IPv6 enabled host, and the router has most probably a statically configured unique global address that is routable in the IPv6 internet. The router is sending out in intervals NDP router advertisements to a specific multicast address called all nodes. Here we can see how it looks like, so he typically sends this message from its own link local address to the multicast address for the all nodes FF02:1, and within the router advertisement he's providing the information of the unique global IPv6 prefix. So it's not telling the dedicated IP addresses for each host, it's just telling that's the network part of this network here, and the hosts receiving this information now, thanks for the network part, then I'm able to generate my complete IPv6 address using this information. And in addition, as you send me a router advertisement from FE80:1, the host knows that this is most probably the default router and installs the default route pointing to this IP address where that has been received on this interface, and is able to configure its IP address. The same as an ARP, if you have Ethernet between two IP nodes, first the Ethernet address needs to be known, and for this we have the discovery protocol as well, NDP. And normally if a host wants to send a packet to any other host in the internet, it first needs to know how to reach the router address. What's the MAC address of the router? And for this, it's sending out a neighbor solicitation to a special multicast address for this use case. Here we can see that it sends out from its unique global address because the host wants to communicate to the outside world, sends out to the special multicast address, which means, let's say, that this address, send packets to this address should receive only by host that ends with IP address, the last 24 bits of the searched IP address. In this case, 00001. And within this message, the query is, what's the MAC address of the IP address, the complete FE80:1. And in normal cases, the router that owns this IP responds back via Ethernet unicast with a neighbor advertisement. So from the requested IP to the source IP, that's with the information of the MAC address of the router. And the host is then updating its neighbor cache and can send the packets, or the packet that really was intended to a host behind the router. Switch one step back. I just want to note here that these multicast addresses normally are only destined to host that joins this group. In consumer level network equipment, they don't take care about this group joining. Most of the FF beginning multicast addresses, they are flooding throughout the Ethernet network, don't care about Ethernet multicast at all. So this request, this neighbor solicitation, would be heard or seen by any host on this Ethernet segment with a low-cost consumer level network equipment. When we now want to poison this neighbor discovery protocol, the attacker running Ettercap is sending out as an ARP periodically neighbor advertisements using unicast, and this 2 times. One time to the router from with a source address of the host with the information of the MAC address of the attacker, and it sends to the host with the IP information source from the router to the host with the MAC address information of the attacker. And this leads to the both nodes that they update their neighbor cache with the poison information, and the router thinks that this IP address, which belongs to host, is reachable via the Ethernet MAC address, which is owned by the attacker. And the same applies for the host. So why do we need to care about IPv6 neighbor discovery poisoning? When you are located in a dual stack network and you do only ARP spoofing or ARP poisoning, you will miss all the IPv6 traffic because ARP just takes care, is limited to IPv4, and therefore we need also to care about the neighbor resolution protocol for IPv6. to intercept all the communication. Let's go through what we just talked about. So in IPv4 it was easy. We had only one address on a interface of a node, either the default gateway and the victim, and you say this is the gateway and this is the victim, and that's it. In IPv6 it's a bit more complicated because we have at least we have definitely multiple addresses, and we need to take care about which address I choose. And when we have both address families enabled, then we have really a lot of IP addresses, at least 3 IP addresses per host. And what we also saw is that with using the stateless address auto configuration, just shown, that this one typically uses the link local address as the default gateway IPv6 address. This is important to know. Let's go and practice a bit. Here I have my machine with Ubuntu installed with Ettercap, built from source with version 0.8.1, and here I have my victim running on Debian, a 32-bit machine. On my attacker, let's first go through the IP configuration, just what we talked about in the presentation with simplified values. Now look at what is how it looks like in reality. First we check what's the address of the interface. We use it by RPA, and we have the ETH0 interface here. We have one IPv4 address and 3 IPv6 addresses. So let's go through them. One is always there, as I said, is the FE80 link local address. Here we can see that scope link, only valid on the link. And we have here 2 IPv6 global addresses. So here we have 2 because privacy extension has been enabled that hide the MAC address within the IPv6 address. But in any time and all the time, the host always has the normal address where the MAC address is being encoded within the IP address. It's called the EUI64 mechanism, and you can identify it with the FFFE pattern in the middle of the host portion of the IPv6 address. Now check out the route. We have a default route pointing to this host, meaning this is our router IPv4 address. And for IPv6 we have, as expected, it's also stateless address auto configuration, the next hop used by the link local address of our router. This is the route information, and what we now need is the neighbor cache information. With IP neighbor we can display this information. It's a bit lot here, so let's pipe it a bit into grep and filter out what we really want to see. So this one for IPv4, and this one is my next hop for IPv6 default route. Here we go. So this is now the information on what we really want to know. We can quickly have a look at the victim. So it looks similar. I just keep let's go to the route to check out if we have the same addresses, and grab out the information for my default gateway for both address families, that we can see that poisoning really does the job with Ettercap. That's a pity. We have the IP. We have one more IP address here, which is not interesting yet for us. Okay, so let's start on my attacker now, Ettercap. I start sniffing. I only have one interface, so I go for unified sniffing mode and open the hosts lists. And here in the hosts menu, you have to check the enable IPv6 scan option, because otherwise you will only scan for IPv4 hosts on the Ethernet segment, and you won't see the IPv6 addresses as well. And then just scan for hosts, and you will see now one time we scan for IPv4 and now we scan for IPv6 active hosts on the Ethernet segment. Okay, here we go. And we see that our list is becoming quite long now. This is because when we sort by MAC address, which I recommend in dual stack network to do all the time, because now you see easily that we have 3 addresses on the same MAC address. Let's think about what we just talked about earlier. We have multiple addresses, at least 3 per host, and this is what we see here. So we have less hosts than IP addresses, as we see here. We have 1, 2, 3, 4 hosts, and yeah, as we expect, with 1 link local, 1 unique global, and 1 IPv4 address. Let's resolve the host names because I don't know my machines by heart of their MAC address. Okay. Okay, we have my Debian machine, my victim. We have another FreeBSD system on the wire. We have something else on the wire, and this is from the IP information. If I look here, this is most probably my router. Okay, I want to poison both address families, so ARP and NDP. So first do the ARP thing. It's normally always the case that we add the IP address for the router to target 1 and the IP address for my victim to target 2. So that was easy. We do it every day. But now we have to think again, what is the default gateway for my IPv6 host? It's the link local address of my router, so add it to target 1. And I want to sniff communication that goes to the internet, so I need on the other side add the global unique address of my victim. So that is a thing that really have to come into mind, and you need to understand that you add for the communication between the router and the host 2 different IP addresses from 2 different subnets. This is how it's working with the Slack approach. Let's shortly check our targets list. That's normal, and then we can go and start the ARP poisoning first. We want to sniff remote connections. We see in a message pane that it picks out only the IPv4 addresses from our targets list, and then in the man in the middle menu, choose the NDP poisoning with the same options. And we see that it's only picking the IPv6 addresses. Okay, now we are in a poison status. Let's check on our victim if it's really the case by just refreshing our neighbor cache information, or the show it just, and we see that the MAC address of my IPv6 default gateway really changed. And the same applies for my IPv4 default gateway information. Now we made our victim think that it can reach the default gateways or router over the MAC address of my attacker, and this redirects all the traffic through Ettercap. We can test this easily on the attacker. Let's open the connections list. only want to see TCP traffic, that we don't get flooded too much. And on the victim, I just do a quick browser check to a HTTP server with basic authentication to make it just easy and to present. First, IPv4. It's a basic authentication. We see here now in the connections list that I see the TCP traffic. I see both directions, so obviously it really works as well on the router. Otherwise, I would only see one side of the communication. And in the message pane, I can see that it really dissected the authentication information and printed there, mark the connection in the connections list, and when we display the details, it will also provide the information that we have passed through the authentication dialog. That was IPv4. Now we do the same test for IPv6. To wrap it in square brackets. Do the same. And here we go. There is our connections for IPv6, and it also marked the connection where we received user credentials, and here we see that it has also been printed on the message pane. And for later use, when we don't check that, we can see it in the connections list. It's listed then in the connections details dialog. So this is how Ettercap is being used within a dual stack network with hosts that have really IPv6 connectivity, internet connectivity, and IPv4 enabled, that you need to take care of both address families, otherwise you only see traffic for one of the address families and maybe you miss the interesting part you intended to see. Okay, yeah. So that was it from my point of view. I hope you enjoyed this video and enjoy using Ettercap, and we will come up with a few more videos showing some interesting stuff. And hope you had fun. Take care. See you next time. Bye.